Welcome back to Kamal Kunj Home Academy, Encounter with Mathematics. In this session, we will discuss side-side theorem. What is this theorem? According to this theorem, if three sides of a triangle are equal to the corresponding sides of another triangle, then the two triangles are congruent. Here given two triangles, triangle ABC and triangle DEF. There are two triangles A, B, C and D, E, F, in which AB is equal to DE, AC is equal to DF and BC is equal to EF. Then we have to prove that these two triangles are congruent. So what is given here? Given two triangles ABC and DEF, in which AB is equal to DE, AC is equal to DF and BC is equal to EF. Now to prove triangle ABC is congruent to triangle DEF. Construction. Draw angle EFP such that angle EFP is equal to BCA, and there existed on ray FP there existed point D dash such that AC is equal to D dash F. Now join ED dash and D dash. Draw angle EFP on the opposite side opposite to D side, opposite to D side of EF. Draw angle EFP opposite to D side of EF such that angle EFP is equal to angle BCA. There exists a point D dash on ray FP a point D dash on ray FP such that D dash F is equal to AC. Join ED dash and DD dash. Now let us consider one-to-one correspondence between A, B, C and D dash E, F. Let us consider one-to-one correspondence between A, B, C and D dash E, F. Here we have BC is equal to EF, it is given angle BCA equal to angle EF D dash by construction AC is equal to D dash F by construction therefore triangle ABC is congruent to triangle D dash EF by side angle side postulate. This implies that AB is equal to D dash E and angle BAC equal to angle ED dash F. Now, line D dash intersects EF. Okay. Now, three possibilities arises. D dash intersects EF. D dash intersects EF at K. Because D and D dash are on the opposite side of EF. D and D dash are opposite sides of EF. Now three cases arise. Now, there are three cases. Number one, K will be between E and F. In which case, if triangle is acute, if is acute, like this. This is an acute triangle. If triangle is acute, then K will be between E and F. Number two, F will be between E and K. In which case, if triangle is obtuse, if obtuse, like this, if obtuse triangle is there, obtuse triangle, in that case, this is EF, E and F, and D will be somewhere here. Sorry, A will be somewhere here. This will be K. If triangle is obtuse, then F will be between E and K. In third case, K will coincide with F. K will be equal to F. If triangle is right. If triangle is right. Example in this case, if it is the right triangle, in that case, both F and K will be same. F, K will coincide with F. Now we will take up first case when K is between E and F. Let us take up case first when K is between E and F. In this triangle, ED dash D. ED is equal to ED dash is equal to, we have proved ED is equal to D dash E. Triangle ABC is congruent to triangle D dash EF. This implies that now AB is equal to D, so this implies that DE is equal to D dash E. DE is equal to D dash E. This implies that angle EDK will equal to angle ED dash K. By isosceles triangle theorem. Isosceles triangle theorem. So angle EDK is equal to ED dash K. Again, in this triangle FD dash, we have D dash F equal to AC. D dash F equal to AC. This implies that D dash F is equal to DF because AC is equal to DF. AC is equal to DF because this triangle ABC is congruent triangle D dash EF. Therefore, AC is equal to D dash F. This implies that since df equal to d dash f, therefore this angle will be equal to this angle, that is f dk will be equal to f d dash k. D dash k, so f d dash k will be equal to angle f d k, right? Associate triangle theorem. So we prove that this angle is equal to this angle and this angle is equal to this angle. Therefore sum of this angle and this angle will be equal to sum of this angle and this angle. Suppose this is 1 and this is 2. Adding 1 and 2 we get angle this plus this equal to angle this plus this. This angle plus this angle will equal to this angle plus this angle. Adding 1 and 2 we get angle EDK plus angle FDK equal to angle E d dash k plus angle F d dash k. Now E d k plus F d k is E d f. This implies that angle E d f is equal to angle E d dash f. E d f is equal to E d dash f. This implies that angle EDF is equal to angle E d dash f is equal to angle A, because triangle ABC is congruent to triangle D dash EA. Therefore, angle E d dash f is equal to DAC. Therefore, E d dash f is equal to angle BAC. So angle A is equal to angle D. Now let us consider one-to-one correspondence between A, B, C and D, E, F. between ABC and DEF. We have angle EDF equal to angle BAC is equal to angle EDF, just proved, and AB is equal to DE. AB is equal to DE, and AC is equal to DA is given. Therefore, triangle ABC is congruent to triangle DEF by side angle side postulate. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.